EJ here. I'm excited about what we're learning in class today, so let's jump right in. What do an ice cream cone, your notebook, and the sun have in common? If you're thinking about temperature or color, or how these three things are used, those are definitely some good ideas. But let's look on a much smaller scale, because what these three things have in common is so tiny we can't see it with our own eyes. It's called the atom. You may have heard of the atom before, maybe on TV or from a book. For something so small we can't see, it's a big thing in science. In fact, it's one of the most important things in our universe. The atom is the key to building what we call elements. If you've heard the words oxygen, gold, and carbon, these are examples of common elements. Elements make up everything in our world. They each have a special chemical and physical feature that let them do different things. Each element is unique in its own way, but there are so many of them, 118 to be exact, it can be hard to keep track of what makes each one special. For example, we want to know which elements are safe for us to use, and which ones should be handled very carefully. So how do we organize the elements? This is where the nifty and helpful periodic table comes in. The periodic table allows us to organize all of the 118 elements so we can study and understand what they can do. But to understand the periodic table, we have to first learn more about atoms and elements. So what is an atom? An atom is the smallest and most simple building block of matter. Matter is the stuff that makes up our world. Anything that takes up space and has weight. An ice cream cone, your notebook, even the sun in the sky. All of these things are made up of matter. Matter is made up of elements, which are made up of atoms. Think of an atom like a Lego piece. Atoms, like Lego pieces, can be assembled, meaning put together, to make bigger and more complicated structures that make up stuff. Like how a Lego piece has special features, such as ridges and holes and edges. Atoms also have special features. An atom is made up of the nucleus and the electron cloud. The nucleus is at the center of the atom. It contains two types of particles: protons, which are positively charged, and neutrons, which have no charge, which is why they're called neutral. The electron cloud surrounds the nucleus. It's made up of negatively charged particles called electrons. Protons, neutrons, and electrons are called subatomic particles. Why are these subatomic particles important? The reason is that what makes an element unique is the number of protons it has in its nucleus. Also, the number of electrons an atom has determines what kind of chemical reactions it can go through. Every element has its own unique number of protons. No elements share the same number of protons. So what is an element? An element is a pure substance that's made up of only one type of atom. This means that an element can't be broken down into any other type of element. For example, the element of gold has gold atoms. The gold atom is special because of the unique number of protons in its nucleus and the number of electrons around its nucleus. Gold atoms can't be broken down into any other types of atoms, like oxygen or helium. It's the same way you can't make a yellow Lego piece turn into a red Lego piece, unless you paint them, but you can't paint elements, unfortunately. You can combine individual pieces to make bigger structures. For example, you can combine carbon and oxygen to make carbon dioxide, but you can't make carbon turn into oxygen or oxygen turn into carbon, because these two elements have different numbers of protons in the nuclei of their atoms. If no elements can have the same number of protons, and it's the number of protons that tell an element what it can do and what it can't do, then the proton is the key to understanding the periodic table. So what is the periodic table? You may already know some common elements, like oxygen, carbon, and helium. But have you heard of the element of niobium? What about mendelevium or zirconium? These sound like they were pulled out of a sci-fi TV show, but no, they're not the names of cool spaceships or alien planets. There are currently 118 known elements, 92 of which happen naturally, while the rest are made by scientists in the lab. The periodic table lets us organize these elements so they're not so jumbled and confusing. How is the periodic table organized? Well, it's changed throughout history. It was first proposed by chemist Dmitry Mendeleev in 1869. As more elements were discovered and created, the table was adjusted to fit new chemical and physical properties. Today, the elements of the periodic table are organized by atomic number. The atomic number refers to the number of protons in each atom. Remember how every element is made up of one single type of atom? And every type of atom has a special number of protons in its nucleus. Because every element has a distinct number of protons, no two elements are the same. So the atomic number is an easy way to organize the elements. Also, each element gets its own abbreviation, like O for oxygen and Au for gold. It just makes things easier instead of writing out a full name. Some of these elements get a little lengthy, like livermorium. Imagine writing that on a table of 118 elements. The periodic table is also organized more specifically by periods and groups. Periods are the horizontal rows across the table. If you look at the table from left to right, you'll notice that the atomic number, which is the number on top of the element's letter, goes up. So as you move from left to right and top to bottom on the periodic table, the elements you see contain more and more protons. For example, hydrogen has an atomic number of 1, while oxygen has an atomic number of 8. There are 7 total rows or periods on the periodic table. Groups, on the other hand, are the vertical columns up and down the periodic table. There are 18 groups or columns, and each group of elements has different properties from other groups. But elements in the same group share similar properties. Let's take a look at the last group on the far right of the table, group 18. This group has elements like helium, neon, and krypton. This group is known as the noble gases group. These elements are quite the loner type. They're what scientists call chemically inert, which means they're happy just doing their own thing. They don't like to form bonds with other elements. But if you look at the far left of the table, you have group 1, the alkali metals. This group has elements like sodium, potassium, and lithium. The alkali metals are the social butterflies of the periodic table, way more social than the noble gases. They're also very reactive, which means they like forming bonds with other elements. There are other groups such as the halogens, transition metals, and alkali earth metals. Each group differs from other groups in its chemical and physical properties, but the elements in each group share similar features. Let's bring it all together. Look at how much you've learned in just a short time. You now know about atoms and subatomic particles like protons, neutrons, and electrons. You also learned about how the number of protons and electrons determine types of elements and how each element is unique. So the next time you see a periodic table, don't be intimidated. You have the knowledge to see not just letters and numbers, but complex chemical and physical relationships that compose everything in our world. As always, thanks for tuning in. Until next time, stay curious, my friends.